Students, welcome back to the second session of our chapter called as Simplex Method. Now in our previous session we have understood what is an objective function, what is a subjective function, what are the non-negative constants. In this session we are going to go ahead and understand how to transform a linear programming problem into a standard form, because once you know the standard form, only then you can go ahead and solve a question using the simplex method. So let's begin, friends, with our today's session. I welcome you all to this channel, Pankaj Lade. Let's start with this topic. In simplex method, as I said, getting standard form is very important. So as you remember, if I have an objective function, now remember that the objective function can be of two different types, a maximizing or a minimizing. When you are transforming a particular linear programming problem into a standard form, now this statement is very important. You listen to it very carefully and you got to remember it. If you have a problem, a linear programming problem which has to be transformed into a standard form, the first thing that you'll be noticing is the objective function. We remember that objective function can be of two different types. It can be a maximizing type and a minimizing type. But when you are transforming it into a standard form, you have to always keep the objective function of maximizing type. If it's a minimizing, you got to transform it to a maximizing type. That means every single time you want to remember that the objective function should always and always be an maximizing type. It should be a maximizing type of objective function. So let us say I have an objective function, maximize z is equal to, so I'm going to make use of n number of variables. So I have, say, c1x1 plus c2x2 plus c3x3 and so on plus cnxn. So do you recall c1, c2, c3? These are called as the cost coefficients. x1, x2, x3 and so on up to xn are called as the decision variables. So that's my objective function. If it's a minimizing function, if it's a minimizing objective function, you will have to transform the minimizing objective function into a maximizing objective function. That's the first rule you should remember for solving a question or transforming a question into a standard form. So the first thing that you want to remember is objective function should always be a maximizing type. It should always be a maximizing type of objective function. So that's the first thing. So suppose in case I have a minimizing objective function. So minimize z is equal to, so I'm going to write an equation, say 4x plus 3y. So that's my minimizing function, z equal to 4x plus 3y. So what I'll be doing here is I'll be transforming this into a maximizing objective function by writing z dash, which is equal to, this is very important, which is equal to minus of z. So what I did here, I simply multiplied the minimizing objective function with a minus sign, with a negative sign. So z dash is equal to minus of z. So I'm going to write it, this is equal to minus of 4x and minus of 4y. So you simply need to do what? If your question is of a minimizing type, what you should be doing is transform it into a maximizing type by simply multiplying the objective function with a negative sign. That's all you should be doing. Just multiply the objective function with the negative sign. So if it's a minimizing objective function, you multiply it with a minus sign and transform it into a maximizing objective function. So that's the first thing you should always take care of while solving or while transforming a linear programming problem into a standard form. So the objective function should always be maximizing type. Now let's write some subjective functions. So if I have the subjective functions, let's say a11 x1 plus a12 x2 and so on till a1n xn less than or equal to type. So as you remember, the objective functions can be of two different types, less than equal to type or greater than or equal to type. So less than equal to type, a12 a21x1 plus a22x2 and so on, a2n xn less than or equal to b2 and so on. If I keep on continuing, say a n1 x1 plus a n2 x2 and so on till a n xn less than or equal to bn. So do you recall in the subjective function, now as I said, there can be two different kinds of a subjective function. It can be a less than or equal to type and a greater than or equal to type. In general, less than or equal to type are associated with the maximizing and the greater than or equal to type are associated with the minimizing type. But that is not a hard and fast rule. They can interchange also. That's just a general talk. So students, subjective function a11, a12, a21 and so on up to ann. These were called as the structural coefficients, x1, x2 and so on up to xn. These are still the decision variables. b1, b2 and so on up to bn are called as stipulations. And later on we had finally the non-negativity constraints, which tells us that the decision variables should always be greater than or equal to 0. Now, you have understood the first thing. The first thing was the question, the linear programming problem should always be a maximizing type. So that's the first requirement. The second requirement to transform it into a standard form is all the subjective functions, all the inequations, less than type or greater than type, should be transformed into equalities. That's my second requirement, students. So my second requirement is all inequations which are present in the subjective function. So I can write here inequations. All the inequations should be transformed into equations. Should be transformed into equations. Now how I'm going to achieve this? All my inequations, I want to transform them into equations. So I want to achieve this by introducing something called as a slack or a surplus variable. So listen to these words. There is a slack and a surplus variable. So you want to understand what is a slack variable and what is a surplus variable. Now, as I said, a subjective function can be of two different types. The first one is a less than type inequation. Less than or equal to type, isn't it? So whenever you have a less than or equal to type, I'm going to write an example. Let us say if I write say 2x plus 3y less than or equal to say 5, or for better example could be say 6. So 2x plus 3y is less than or equal to 6. That's my inequality. That's my inequation. It's a less than type inequation. I want to transform this into an equation. Now did you observe a less than type indicates that the left hand side is less than the right hand side, isn't it? Less than type inequation is simply indicating that the LHS of this inequation is less than the RHS of the inequation, isn't it? Now if it is a less than type, I want to transform this into an equality. See, what should I do? I will add something to the left hand side so that it becomes equal to the right hand side. I'm going to add something to the left hand side so that it becomes equal to the right hand side. So I'm going to write it as 2x plus 3y plus say s1. So that's my slack variable. This is in less, isn't it? This has something less. It is in slack of something. So I'm going to give him something so that it becomes equal to the right hand side. It becomes equal to 6. So this s1 is called as a slack variable. So the second point, as I said, you have to transform the inequation into what? Equation. Inequations can be of two different types. The first type was less than type, less than or equal to type. If you have a less than type, the left hand side is less than the right hand side. So you want to equate it. So you are going to add something to the left hand side so that it becomes equal to the right hand side. So this added variable is called as a slack variable. I'm going to call it as a slack variable. As many inequations that many slack variables will come. So if there are n number of inequations, if I have n number of inequations and all inequations are of less than type, then obviously I will need n number of slack variables to be added. So the first slack variable to the first inequation, second slack variable to the second inequation, and so on, the nth slack variable to the nth inequation. So the first thing you should remember now is whether it is a less than type or a greater than type. So less than type, you add a slack variable. Suppose you have the second type of inequation which is a greater than or equal to type. If it is a greater than or equal to type. So again I'll write an example. So I write say x plus 4y is greater than or equal to say 8. Now this time the left hand side has something more than the right hand side. That is why it is greater, isn't it? So the left hand side is having something in surplus. Are you getting it? You have something in surplus. So this amount which is in surplus has to be removed from the left hand side. So if I want to remove it, I should subtract it. So I'll write here x plus 4y minus say s1, if I again call, it becomes now equal to 8. So this is called as a surplus variable. So there are two different kinds of variables that you want to remember. One is called as a slack variable and the other one is called as a surplus variable. The two different types of inequations that you have is nothing but what? A less than type or a greater than type. If you have a less than type, you get a slack variable. If you have a greater than type, you get a surplus variable. Slack variable needs to be added and the surplus variable needs to be subtracted. So this is the second point you should always remember while doing transforming or transformation of a linear programming problem into a standard form. So the second point. Let's move to the third point. Now, as I can see that you now don't need this particular concept. We've already learned this in your previous session. So I'm going to remove this part from here. Okay, but just remember that you have a subjective function, objective function, and you have the non-negativity constraints, and we are transforming a linear programming problem into a standard form. And why we are doing this? Because we want to solve a simplex method problem, isn't it? We have to learn what is simplex method, and the base of simplex method is transforming the linear programming problem into a standard form. The first rule of standard form, the question should always be of maximizing type. If it is a minimizing type, you transform it to a maximizing type. The objective function should always be a maximizing type. You simply multiply the minimizing equation with a negative sign, it will transform into maximizing type. The inequations should always be transformed into equalities. So you have a less than type, you have a greater than type. If you have less than type, you need a slack variable. If you have a greater than type, you need a surplus variable. Slack variable gets added and surplus variable gets subtracted. The next thing, the next point you should remember, the third one, is the right hand side of the inequation has to be a non-negative number. Listen to this statement very carefully. I said the right hand side of the inequation. So subjective functions are the inequations. Right hand side b1, b2, b3 and so on up to bn, they were called as the stipulations. So this right hand side of the inequation always has to be a non-negative number. So when I say non-negative, it means either it can be a positive number or it can be zero, but it cannot be negative. It has to be a non-negative number. So that's my third rule. The right hand side, the RHS of the inequations, that is, you call them as stipulations, should be non-negative. This is very important. It should be non-negative. That is either positive or it can be zero. So that is what the third point is. So if you have an inequation whose right hand side is negative, obviously you have to transform it to a positive sign and then check out whether it is a less than type or a greater than type. So I'll take two examples for this. Suppose if I have say 4x plus 3y less than or equal to, or I'll change it to minus also, let us say 4x minus 3y less than or equal to say minus 12. So the first thing that you should be doing is you have to get rid of the negative sign from the right hand side of the inequation. So it should not be minus 12, it has to be plus 12. Now remember this, I can make it positive only by multiplying it with the negative sign. That is the only way possible to transform the negative sign to a positive sign. But now remember this, if you are going to multiply this inequation with a negative sign, the inequality will transform into an, what you can say, greater than type. This inequality, the less than type will transform into a greater than type. This is very important. So I'm going to multiply with a negative sign, then the inequality will change. That means I can say minus 4x plus 3y, and that's what the change you are going to observe. It is going to be a greater than or equal to type, and the right hand side now becomes plus 12. So what kind of an inequation this is? It is now a greater than or equal to type. So this will need something called as a surplus variable. So I'm going to put up a surplus variable, so I can write it as minus 4x plus 3y and minus s1. The surplus variable needs to be removed, isn't it? And greater than or equal to changes to equality now and 12. So that's the first example. Let's take one more example. If I write, let us say 7x, or I can write minus 7x and plus say 2y and greater than or equal to say 14. That's my second example. Now it's a greater than or equal to type inequation, isn't it? And I'm going to put a negative sign here because that's what my requirement is. The right hand side contains a negative sign. The right hand side of the inequation contains a negative sign. But my requirement is it should always be a positive sign, or it can be 0. That means it should be non-negative. So my basic motto here is to remove the negative sign. It can be done only by multiplying both the sides with the negative sign. So let's do it. So I'm going to multiply both sides with the negative sign. So what do I get? I get 7x minus 2y. And what happens when I multiply with the negative sign? In the inequation, what happens? This sign, the greater than sign, will now transform into a less than type. So less than or equal to, and obviously this negative sign goes and becomes plus 14. Now what kind of an equation is this? This is a less than type. If it is a less than type, that means it will now need a slack variable. So I'm going to write it as 7x minus 2y plus s1, and it transforms into an equality. So this is the third point that you should be remembering while transforming a particular while transforming a particular linear programming problem into a standard form. So the first point was what? You should always have an objective function which is of maximizing type. The second point you want to remember is if it is less than type, you add a slack variable. If it is greater than type, you remove a surplus variable. The right hand side of the inequation should always and always be what? It should always be a positive value. If it is a negative value, you simply multiply with a negative sign, but the multiplication with a negative sign will change the inequality sign. If it is a less than type, it will transform into a greater than type. If it is a greater than type, it will transform into a less than type. So far so well understood?